So I've done quite a bit since the last video. I pretty much rewrote this shader from the ground up. In the end, it still does the same thing, but I've added a lot of performance things like keywords in here. So I have different keywords. I'm going to make a full video explaining everything in HLSL that I know of and how to use keywords, how to increase performance on your shaders. So I'm not going to bother going over all that stuff, but I have added the dark visor to my project. So in this pass, we're going to do similar things to the last couple. We're still passing the same values. In this one, we have a few keywords, whether or not it has dark map, highlight, animate textures, and then one that's just dark invisible. This is just to make it so it doesn't bother doing anything if we say it's invisible to that visor. So we still need our base map, our dark map, and our bump map. And then we get a few different values in our command buffer. And then down here, we're going to take in, same as before, our position, get our clip space position. Our UV is going to be tiled and offset if we have that. We're going to get the world position, the normal in world space, as well as the tangent normal in world space. In our actual frag shader, this is that dark invisible part I was talking about. So if it's dark invisible, it just discards the shader. It completely ignores compiling everything else. And then what we do is we take in the UV. This is for animation if the texture is animated. And then this is the math for figuring out our normal. So we need to take in the normal in world space. And then if we have a normal map defined, we need to get our tangent, which is going to be the tangent space of our vector. And then what we do is we get the bitangent, which is the cross product of the world space normal as well as the tangent normal. And then we multiply it by the W component of our tangent, which is the handedness. Then we create a tangent bitangent normal matrix. And that's just a 3x3 matrix made of these three values. Then we sample our normal map, we unpack the normal, and the final normal is going to be a multiplication of our unpacked normal from the normal map times the TBN matrix. And we return that. If there isn't a normal map, we just say the final normal is equal to the normal in world space. Then what we do is we do n.v, which is the dot product of our normal and the view direction. So we need to first make sure it's saturated, so that way it goes between 0 and 1. And then we get the dot product of our final normal and the normalized view direction. Unity has this exposed as an available macro, so you can just call this, and you need to give it the position in world space. The dot product returns how close two vectors are to pointing near each other. So if they're 1, they're perfectly parallel. If they're 0, they're perfectly perpendicular. If it's -1, they're facing in opposite directions to each other. We don't want that. We don't want to ignore anything below 0. So we saturate this to clamp it between 0 and 1. And then we get our base sample. This is just the general grayscale formula. If you Google grayscale formula, it'll show you this. You just take each channel, multiply it by these values, and then add it all together. We set a start color for our lerp to be the grayscale, and an end color to be black. If it's transparent, we also take in the base sample's alpha. Otherwise, we just set the alpha equal to 1. Then if this is a highlighted object, so if you've played Metroid Prime 2, you know that some objects appear red, some of them are just gray. So in this case, we override the lerp end color from black to be emissive red, so 500, so this is a bright emissive color. And then if we don't have the dark highlight, what we do is we just take the grayscale, multiply it by our n.v value, and return a float 4 of the grayscale and the alpha. Now, if we have a dark map set, instead of just using the base map here and applying this highlighted color across the whole thing, we get a dark sample. And then if not, we just set it equal to the grayscale. And then the dark color here is the alert between the start color and the end color by our dark sample. So this means that it'll go between the grayscale and the red by the value of that dark sample. For a lot of my stuff, I'm just using the emission property of, or the emission map of the material. And that way it makes it look wherever it would be glowing, emissive, it's now red instead of gray. Then we multiply it by n.v, we create a color out of it, and we return it. That's all there is to this. It's not a super complicated shader. Realistically, this is probably one of the easier ones. So if I go into play mode here, and I press 4, now we're in our dark beam. So you can see that on the things where I've set it to be the emission texture, it's only glowing red where it isn't. If I haven't set it to be to have a dark map, then the whole thing just glows red. So for something like this platform up here, we have that. I do also have a dark only material. This one, what it does is you have a dark map and an outline only bool. This outline only basically tells it to use Fresnel mapping to figure out where the edge is and only show the edges. I am doing this in the bad way. You're not supposed to, because this is dynamic branching. It really shouldn't be this way. I just didn't have the effort to create more keywords. And then we do a similar type of thing where we're just returning the n.v of the normal. In this case, I'm only using the normal in world space. I'm not using a tangent space normal. I was starting to reach a bit of the end of my rope with working on this project. I want to work on other things, so I've slowed some stuff down, haven't gone as in-depth. So I've just created a quick model and set it here. So now if I set this to be outline only on this material, you can see it has the Fresnel. If I clear the outline only, then it just turns red. So this is to recreate that effect where, you know, oh, if it's in a different world than the one you're currently in, you can only see the outline, you can't interact with it. So that's pretty much all there is to this. Since I didn't have it originally in the renderer feature, you do need to add a tag for the dark mode, and make sure that it matches the tag on the shader. So if I just quickly go back to the shader here, you can see up at the top, it has the light mode dark. So make sure that that is in there and that you have the appropriate values in all your different controllers, whatever you want, to be able to have this feature enabled. There is a little bit more I'm going to do with this, but I'm going to go over the echo first because there is an additional effect that I'm going to add to the dark visor later, but it's kind of the base of how the echo works. So I'm going to cover that in the next video.